It's asking us to find the equation of the tangent and the normal line. I never really reviewed this because I had you all in Algebra 2 and in pre-calculus, and most of us already know it. If I want to write the equation of a line, I really have to have two things. What are those two things I have to have?
Slope.
Slope and a point. Okay, so I have to have two things. I have to have a point, an x and a y, and I have to have a slope. Well, I already have my first part of my point. I already have x equals 1, so I know that. Okay? During this process, we will find the other two. In fact, this process that we walk through, the definition of the derivative, actually gives us the slope, correct? The slope at one exact point. Okay? So, does someone remember the formula that we used? Find the equation of the tangent line, the normal line, we have to find the slope. What's that formula that we use?
F of x plus, was it delta?
F of x plus delta x.
Minus f of x over delta of x.
Over delta x. And you're missing one part to it.
The limit of delta x approaches 0.
The limit as delta x approaches 0. That's the process we're looking for. And by the way, what this first part that you gave us, this part here, we had a name for that. What do we call that? Yes.
Definitely.
Can you define delta x again, please?
No. What did you say?
The definition of a derivative.
Okay, the whole thing is the definition of the derivative. Just this part without the limit, just that part.
The difference quotient.
The difference quotient. Okay. What did you ask there, Teddy?
Can you define delta x, please?
Okay, so remember we drew a graph,
Yeah.
all right, and we picked a point x. Then we picked a second point over here, and the distance between them is the change in x. So that means this point over here is x plus delta x. So the definition of delta x would be the change in x, how x has changed.
Okay.
And remember, delta x can be
Bless you.
0.1, it can be 0.01, 0.001, 0.000001. The delta x is getting smaller, smaller, smaller. Thereby, we're taking the slope. When delta x is 0, then they're both at the same place. Okay. Because if x is 1, this would be 1 plus 0, which would also be 1 to be the same point. That's what we're getting to. We're getting the limit as it gets closer and closer and closer. Very good. Other questions?
Well, I have a question I'd like to say. So they couldn't scan it with their computers. So they had to check them. But
So we got the information there, right?
yeah, I understand.
Okay, very good. Other questions? Not about statistics? Stats is doing a first chapter of the chapter project, so sorry they had to leave in the second round. Probably will happen again, just saying. Okay. Yes?
To find the y value of the point, why don't you just plug the x value into the equation?
We're going to. Right here. So when I get that value, I'll know what y is.
Okay.
Yep. Other questions? Okay, so what's the first substitution I make? In place of x, I know what x is. So I can go ahead and write the limit as delta x approaches 0. By the way, when you're doing this on a test or whatever, I do need to see all the steps. Okay. Of x plus delta x, so here I have f of, instead of x I put in 1 plus delta x. Minus f of 1 all over delta x. So we simply replace the x with whatever value I'm given. So in this case, I'm given x equals 1. I want to find the slope at 1. I want to find the tangent line at 1. So I plug in 1 for x. So then I'm going to have the limit as delta x approaches 0. What do I now do with 1 plus delta x? Lachlan just told us.
Plug in x for the y value.
Plug in 1 plus delta x every place you see x. I'm going to plug in 1 everywhere you see x. Okay? So I'm going to go 1 plus delta x squared minus 4 times 1 plus delta x. Okay? So that's the first one. That's plugging in 1 plus delta x in for the function. And then minus, what is f of 1? Want to come over to the side. F of 1 is going to be equal to 1 squared minus 4 times 1. Gives us negative 3. Now, as Lachlan said earlier, that is my y value. That's taking 1 and plugging it in, so now I have my full point. 1, negative 3. That gives me my y value. All over delta.
Wait, where'd you get the negative 3 from again?
I plugged in f of 1. See, it says f of 1 here?
Yeah.
So I plug 1 into my function. 1 minus 4. 1 squared minus 4 times 1. Gives me negative 3.
And then why'd you add it? Oh, never mind. Sorry. Because of that.
Because of the function.
Yeah.
Minus f of 1, so minus negative 3. Good questions. Keep them coming. All right, so then, we're going to simplify a little bit. I have the limit as delta x approaches 0. Honestly, if I still put in 0, I'm going to get, let's see, that's going to be 1 minus 4 plus 3 is 0 over 0. So I'm going to get 0 over 0. So what is 1 plus delta x squared? If you need to do that to the side, it's 1 plus delta x times 1 plus delta x. It would be beneficial to you if you did that shortcut, or able to do that quickly. It's going to be 1 plus 2 delta x plus delta x squared. Distribute out the 4. So negative 4 times 1 is going to be minus 4. Negative 4 times delta x is negative 4 delta x. And then minus negative 3 is plus 3. So that's just a matter of multiplying everything out. What'd you say? You said something.
Yeah, you said no.
As you're writing down that mess, what cancels? How do I simplify that?
The minus 4 delta x and plus 2 delta x.
Okay, those two are like terms. That's going to become negative 2 delta x.
1 minus 4.
What is 1 minus 4?
Negative 3.
And negative 3 plus 3 is?
2.
Now, what did I tell you about that?
That always happens.
Your constants should always cancel. Using the definition of the derivative, your constants should always cancel. If they don't, you made a mistake. So 1 minus 4 is negative 3, plus 3 is 0. So then I'm just left with plus delta x squared over delta x. Okay, what do I do next? Because honestly, if I still plugged in 0 for delta x, I still get 0 plus 0 over 0. So what can I do?
Factor.
Factor what?
The delta x.
Absolutely. So we have delta x on top. I factored out negative 2 plus delta x all over delta x. Which then gives me the limit as delta x approaches 0. These cancel, and you're left with negative 2 plus delta x. Therefore, what's my answer?
Negative 2.
Negative 2, because you just put in 0 for delta x. You direct substitution, and your answer is negative 2. So what is negative 2? That is my what?
Your y
Slope.
value?
Nope. Slope. That is my slope. That is my slope.
All right.
Pretty simple, right?
Very simple.
Lots of algebra.
Elementary.
Lots of algebra.
How'd you get negative 3 for the y value?
How did I get what?
Negative -3 for the y value.
So right here, when I found f of 1, so f of 1, that is the y value at 1. So when I plugged it in, 1 squared minus 4 times 1, I got -3. So this right here is your y value.
So when you plug in whatever
Hey,
x is
quiet
the
please,
x.
when people are asking questions. I need to be quiet.
So whenever you plug in the x value to f of x, and then you plug that into the function, that'll give you your y.
Correct. I mean, that's how we find the y value. Very good. Other questions about this? All right, so I have the point 1, -3 and the slope of -2. So I have 1, -3 with the slope of -2. Was it -2?
Yeah.
Yeah.
Okay, so then what's the equation of my line? Y minus a -3, -2, x minus 1. I use my point slope one, which we change to y plus 3, -2, x minus 1. And what's the best way to write this answer? I mean, that's technically the,
And slope 0.4.
this is point slope form. But if we want a true equation, get y by itself. So subtract 3. You don't need to go any further than that. That's perfectly fine for your answer. If you want to do slope intercept, you're fine, distribute and stuff, but if you make a mistake, I gotta take points off. So just leave it like this. And this is the tangent line, correct?
Yeah.
Because that's the slope of my tangent line. So how do I find my normal line?
What makes it the tangent line?
Because it's going to touch the graph at one point. We've got, the function was a quadratic, right? And, whoops. It's going to touch it at exactly one point. That makes it a tangent line. So how do I find the equation of the normal line? Yes?
Do you take, is it 1/2 x minus 1?
Yeah, you just take the negative reciprocal of your slope. Everything's the same. Y minus the -3 equals, but you take the negative reciprocal, 1/2 x minus 1. So then you have y plus 3, 1/2 x minus 1. So y is going to equal. So you see it's exactly the same equation, the difference is your slope, negative reciprocal. And the normal line then would be something like that. Well, that's 19. So here's your tangent, and here's your normal. That really should be back from Algebra 1. We haven't done anything different from there. That's just kind of point slope form. So don't think there's anything new there, but you do have to be able to take it to that step.
I suppose. Well, how do we find the tangent of the normal line?
This is just an application of the process, one of the questions we asked. I could have asked on this one, rather than find the equation of the tangent normal lines, I could have said, find the slope at the given point.
Okay.
Then it would just be -2.
That's just, okay, that's just what the question was.
Or I could have, there's like 7 things I could have said here. Find the slope of the tangent line, find the slope of the normal line, find the instantaneous rate of change at the given point. I mean, there's lots of things we could say.
Yeah.
Find the derivative at the point. Okay. So, but it's all the same process. And if you can remember what exactly this -2 is, whoops. If you can remember what exactly this -2 represents, then that should, there's lots of ways to say it, so you should understand that process. Okay, very good. Questions about this one? How close are we to starting and trying one completely on your own?
I think I'm gonna.
Start to finish?
One more.
Give me a 3 if you're ready to start this completely on your own. No. 3. 2.5. That's not a 3.
I've never had to do like 0.
All right. Looks like we need to do maybe one more example together. And what I don't want to happen though is I don't want you to do this and then forget what it is we're solving. Remember what we're solving for. What are we solving for? What part of the tangent line?
Slope.
The slope of the tangent line. That's what we're looking for, the slope of the tangent. What type of rate is it? What type of rate of change is that?
Instantaneous.
Instantaneous. It's at the second. Okay, instantaneous rate of change. That's what we're looking for. I don't want you to get lost. Okay, all those examples are a little more challenging. Let's do a word problem.
Oh, that's it.
And it will walk you through the same thing. Okay, here we go. Example number 3. An object is dropped. This actually takes us back to the very first problem, I think, in 2.1. An object is dropped from 100 meters. Given S of t, so I've changed the letters a little bit, just so you know, typically in calculus, S represents position, like where is it at? So S of t, if I give you a function, it's like, okay, where is it at S equals 0? Where is it at S equals 1? How far has it moved? You know, where's its location? So S is usually position. So S of t is going to be equal to, it starts at 100, minus, and then we have gravity, 4.9. And I think I want to use t squared here. T squared. Okay. And then it says, okay, so how fast is the object traveling at t equals 2 seconds. At t equals 2 seconds. Okay. So it drops from 100 meters. You can tell gravity 4.9 squared, t squared is dropping. It tells you its position. So we're basically saying, what are we asking for? How fast is it traveling?
Its position.
Now we're looking for its position. How fast is the object traveling?
At a certain position.
So what are we looking for? Now position.
The slope, the change.
The change of its position over time. What do we call that in generic terms? Speed.
Velocity.
Velocity. Okay, so what's the difference between speed and velocity?
Speed is at its current time and velocity is over time.
Velocity is like distance, like speed over distance.
Well, velocity is like miles per hour, right?
Yeah.
So speed. Does anyone know the difference between speed and velocity?
Isn't velocity how fast you increase, and speed is just how fast you're going?
How fast you increase is acceleration. Yes.
Velocity is like Michelle said, I'm going 25 miles per hour in like the west, and speed is just like I'm going 25 miles per hour.
Did you hear what it said?
Yes.
So the difference between speed and velocity is velocity has a direction. I'm going positive, or I'm going negative, or I'm going east or north or south, or up or down. Whereas speed is just, I don't care which way I'm going, I'm just traveling at a certain speed. Okay? So we would say then that velocity equals the absolute value, I'm sorry, other way around. Speed equals the absolute value of velocity. Okay? So that's what we're looking for here. We're looking for how fast is the object traveling. We're looking for its speed or its velocity. So what we have to decide is how fast is the object moving position-wise over time. So we're going to take the limit. Now in this case, it's not x. We're not going to put delta x. We don't get caught up in variables. What's changing here?
SFT.
I'm sorry?
SFT.
Not S of, well, the S of t is changing, but just t, my time is changing. So the limit as delta t approaches 0, and then it's going to be S of t plus delta t minus S of t all over delta t. Still the same exact equation, except now the letters stand for something a little different. Rather than a function in terms of x, we have a function in terms of time. And that function is position, S of t. Right, and in this case, t is gonna equal 2, so I can go ahead and do, put in my value. So the limit as delta t approaches 0 of s of 2 plus delta t minus s of 2 over delta t. So you do the next step for me. Take s plus delta t and plug it in. Take 2 and plug it in and rewrite that numerator. Take a second and try that. I think it's about time to break out calculators. What do you think?
Yeah.
Yeah.
They're right over there if you want to get them. I need to get you your calculators. We've got special ones for calculus class. We have special ones.
I use this one.
You can, but I have more special ones for you.
Does anyone else want one of these?
Sure. Yeah.
Here. Which one?
Like, do you know like what type is it? Texas inch?
Say again?
Is it Texas instruments like a special one?
It's actually like the yellow ones, but it's a cat. They have a college algebra.
If it's like black?
Yeah,
Okay. I know what you're talking about.
Yeah, I have one, and then we've got a set of them for calculus class. You really don't really need one more than just for this class, you don't need more than scientific. But the graphing one will help us. It allows me to do some interesting things on tests.
Oh, there you go.
Yes. Are those dead?
He's got one.
I will need to get them plugged in. I have the charger I sent plugged in. I'm very sorry. They might all be dead, honestly. You can use Desmos.
That won't die on me.
Hopefully.
Unless a computer does.
I gotta fuzz it.
Not unless a computer does.
Are we good with the green?
Yeah.
We good with the step?
I messed up my computation.
Did someone check my 80.4? I'm pretty sure that's right, but did someone check that?
I heard like 82, sorry.
You're right.
It's 80.4. I need one more person to confirm that. Working on it over here. 100 minus 4.9 times 4.
How do you get that S equal to 100?
Yeah, that's right.
How did I get the
We
S
plugged in,
equals?
we plugged in 2 times.
Because it doesn't plug
delta
anything
T.
into a hundred.
100 just stays there.
So So I took this function, this is my S function, and in place of t, I put in 2 plus delta. And then to get 80.4, I took 2 and plugged it in. All right, and I've had independent confirmation. You agree with 80.4?
Yeah.
All right, so then, let's go to, so now I have the limit as delta t approaches 0. And by the way, I want you to step up your game a little bit, notation-wise, and please write this every time. I'm writing it every time. If we don't, we're gonna forget about it. It's bad notation. Write limit as delta t approaches 0 every single time. Okay. So then I have 100 minus 4.9. What is 2 plus delta t squared? Did anyone do that yet?
Wait, which one?
I'm right here. What is 2 plus delta t squared?
Oh, I got 4 plus 2 delta t plus delta t squared plus 2 delta t.
So 4 plus 4 delta t plus delta t squared, right? Did you say 2 delta t twice?
Yeah.
Oops. Minus 80.4
Mm-hmm.
all over delta t. So all we did here was we took 2 plus delta t times and just FOILed it.
But my addition sign and my T are very similar.
Same.
It's not-
Sorry.
You put like a little, like at the bottom of your T's.
I tried to. Kind of differentiate it from the plus sign. All right, see if you can finish this up. Okay, we're going to distribute out the negative 4.9. See if you can simplify all the way down to one answer.
That's-
Don't get bogged down in the algebra. Too late.
What?
and then so,
Well, just distribute it out. Can you copy that?
But this stays pretty close because you distribute a negative.
I think it's a minus.
I mean, would you distribute it as a positive or a negative?
I distribute as a negative. Negative 4.9, so it's going to be negative.
So it'd be 100 plus then?
Oh, either way. Just keep your sign straight, yeah. Yeah, if you distribute off the negative, I would just go ahead and get rid of the parentheses. Because once you distribute it, you're getting rid of parentheses.
Oh, yeah, you're right.
So then it would be 100 plus negative or 100 minus either way.
Yeah.
What is that? All we're doing is finding the slope. All we want to know is the speed. It's how fast it's traveling, so that's the slope.
Is this part of the answer?
No. What happened here? How'd you go from here?
4 delta t plus, well, because the constants are supposed to cancel, right?
Not until the end. Because you take that negative 4.9 and distribute to all of them.
Is that right?
Yep.
Yes.
Success.
Yes.
Love it when plan comes together. Where'd you go? Did you distribute this out? Take the negative 4.9 times each one of those. Same place. So you have. You what? Oh. So you take the 4.9 and distribute to all of these. Just multiply it out. So where'd you get 1.5? Oh, yeah. You can't, no, because you gotta distribute first. So 100 minus and then distribute.
Isn't my answer for the point?
No, your answer is your slope.
Well, the slope of the
Oh, I
water.
see what you did, yeah, that's fine. But, how'd you get that?
Because like 3 times 4.9, put it in the equivalent of delta x.
You say it, man.
Okay.
Yeah, X is 2, delta X is approaching 0.
Okay.
Minus whatever you get from
Yes, that's correct.
Okay, I figured it, fixed it.
How'd you get that? Okay, so let's go ahead and do this. We have 100. And I'm gonna distribute out, so what is 4.9 times 4?
Negative 19.9, or 19.6.
Negative 19.6. And then what is negative 4.9 times 4 delta t?
Negative 19.6 delta t.
Negative 19.6 delta t. Okay, so then what is negative 4.9 times delta t squared?
Negative 4.9 delta squared.
Negative 4.9. Don't make this more challenging than what it is. You really are just distributing that to each one of them. We're not making any substitutions yet. We're just distributing it out, making the algebra. Okay, and then I have minus 80.4. And then Teddy, this is where the constants, look at this. If I take 100 minus 19.6, I get 80.4. And 80.4 minus 80.4 is 0. Okay, so don't try and cancel anything early, even though you know it's coming, don't try and do it early. Okay, wait until you multiply everything out. And we really are just distributing, just going back to basic algebra. Okay. So we had a couple people get the right answer. Did you change your answer?
Yeah.
What'd you
figured
get?
it out. I got negative 19.6.
Okay, delta t approaches 0. We know that this is going to be 80.4 is gone. I know there's a delta t in all of them, so I can just cancel it out, and I have negative 19.6 minus 4.9 delta t, which gives me negative 19.6. What's the units on that?
Is it
Second?
just
Meters per second?
Meters per second, because it's a rate. So it has to be, we're covering negative 19.6 meters per second. That's how fast, And it does make sense that we came up with a negative, right? I dropped it,
Yeah.
so it's falling, so my distance is negative, it's going down.
Alright.
If distance, or not distance, the speed is negative, it's going down, so that's my velocity. Oh, by the way, here's how you notate that, okay? Little side note ready for chapter 3. What we found was the velocity in terms of time, correct? Negative 19.6. That is notated, let me put it in different colors so you can see it. That is notated S prime of t. S prime.
That's fine.
That means it's velocity, it's derivative, if you will. S prime of t. We'll deal with that more next chapter, but kind of give you a preview. So that means, what that means is I drop this object, if in exactly 2 seconds I shoot it with a radar gun, tell me how fast it's traveling, or if it had a speedometer, it would tell me it's traveling at negative 19.6 meters per second. That's how fast that thing is. So you tell me real quick, reflect on this a little bit. What's the difficult part of this process?
Algebra.
Is this setting this up difficult?
No.
No, you should have that one memorized, right? Is plugging this in difficult?
It can be,
Say it again nice and loud.
Algebra.
The algebra.
I think I'm just.
Those of us who are weak algebra skills, that's gonna be your challenge right there. It's not so bad, is what you said?
There's just a lot of steps, so it can be easy to get lost.
And there's tons of computation on this, so you have to make sure every multiplication is correct. Which is kind of nice though, by having that check to make sure, oh, these didn't cancel out, I screwed up somewhere. You know, I did 2 minus 3, it gave me negative 1, I should have 0, so that's a good check to see if you messed up. Okay, I have one more example I'm gonna put on the board, I'm gonna let you guys work in groups if you need to, don't try this on your own, work with a group of you, and then give me the answer when you're done, and then we can work with some homework, okay? But I wanna give you one chance to try it again, all the way through, step for step. Let me see, how difficult should we make it?
Is it gonna be like a word problem?
Super duper.
It's not gonna be a word problem, I'm just gonna give you a straight f of x. F of x equals
Does this?
x squared minus 2x plus 1 at x equals, I wrote down 2.
Whole numbers that don't have any difference in t's next to them. And then since all of
Okay.
this is divided by.
So
difference,
just find,
that gets your root of 1.
now that you know
That's like
what
over.
the notation,
So
just
that
find
turns into
f
19.6.
prime of x.
That turns into 19.6.
Or we could say the
and that
slope
turns into 4.9.
at x equals 2.
If there's one, you're one.
Find f prime of x, or you could say find the slope at x equals 2.
You're dividing all of this by difference in t. So if you took 19.6 difference in t minus 4.9 difference in t squared, you're dividing both of those by the difference in t. So they both get 1 canceled out. You understand?
Now we can all divide people or speed.
Work together. Oscar, the other way to think about that is, what do these have in common?
The difference of two things.
So if you factor it out,
Oh.
all over delta t, then they cancel.
my say
Thank you.
So then you're
No,
left
we
with,
don't know.
does that make sense?
Yeah.
I heard you explaining it, that's just another way to look at it too.
So we got.
Okay.
Yes, I am, bro. I don't know.
And you're gonna be doing that on every one of these problems. Every one at the end, you're gonna have that, everything's gonna have a delta t in it. So you're gonna factor it and cancel it.
Yep.
You plug it into. Alright.
I'm ready to use a whole page to one of my
Okay, as soon as you know the answer, let me know. Check your work.
Okay, and then F of two would be minus four plus one, so actually, F of two is one.
Would that be right, having it like that?
Yeah, so that's probably doesn't count.
You're right, so that should have been, so 2 plus minus 2.
Alright, so.
Or does the F of two
Well,
change?
You should put x squared minus 2x plus 1,
And then find
and
the
then
F
minus
of
f of 2. And then just put that one number there. Yeah.
Is it gonna be like settled like this?
On accident.
How'd you get?
Minus
2 plus
Yeah,
so should go here.
Well, how'd you get?
Because just like the
plug in this.
formula.
For X. So, you plug in, so X is, so yeah.
Okay.
2 plus delta X squared.
Yeah, I just forgot.
2 plus delta
Yeah.
X 1.
I've been doing it a little bit kind of
For this
subtly
part,
on
just
here,
plug in 2 to
where
this.
I kind of put brackets around this,
So that's 1.
if that helps.
2 plus 2 squared.
Think of it in terms of that.
Yeah, that's 1. Plus 1.
So
wait,
we're
that's
a
a
positive
minus.
number,
Minus
does it
1.
stay
That's
as
a minus.
minus, or do I change it to positive? After,
Over.
F of 2 is a positive,
It's, we know that.
so it's minus
theme-
whatever.
They release the theme really early. They don't release the competition until the season starts. The theme is ocean.
So if I have that, like, what's my plug?
The high school one.
And then it's going to use, okay.
So 2
And now
goes
I'm
into
just gonna put is like.
Or all that.
Diving.
Every time you see X,
It's like
every
a
time you
theme,
see
like,
X,
remember-
you plug in.
No,
Remember
that's,
in middle
delta
school,
x is a
we had, like,
variable x cell.
each year.
So it's gonna stay delta.
And then so then we have 2 plus.
Then minus.
It's barely, actually,
And then all
barely.
over that.
It's just like to differentiate each year. from each
So
other.
now you're
Which
gonna take
is-
this and plug it in where x is. Then
Nah, that's gonna get
you're gonna take
going.
2 and plug it in where. You do 2 separate parts.
So two squared.
It's just for fun though. The
So
theme doesn't
then,
actually
in
change
place of f
anything.
of 2, you're gonna put,
This.
yeah, which is,
You
guys are- oh, you can do it. 4 minus. This one minus 4 is 0, 0 plus 3. So in place of this, you can put 1. So it's minus 1. You got the whole thing. Because you got rid of the whole thing. All of f of 2 is 1. Mhm. And then you have whatever this plugged in is. That's where you're gonna get that long, big string of numbers.
Yeah, so yeah, that's just. 2 times. Yeah.
I just plugged it up. I'm so annoyed.
So what cancel? 4.
it's not, oh, oops.
Yes.
Oh, no, understand.
I would be very mean right there. I could say a lot of things, really cruel. I'm gonna be very good about that though. So keep my mouth shut.